Okay, this is the final video for week 1 on percent solution. It's just going to involve solving some more problems using percent solution. Okay, let's look at this problem. The key to solving these problems is always to find the strength. So that's the first thing I always do. I find the strength, and right here it is. This is a 1/4 strength Cestacol. And if you've never heard of Cestacol, Cestacol is a liquid. It's a nutritional supplement like Ensure. So this will be liquid that is diluted. Now, this is in that form of part to part. So I want to kind of look to see what volume measurement they use. They use ounces. So this 1/4 strength is going to translate into 1 fluid ounce of Cestacol per 4 fluid ounces of solution. Now I have this little illustration over here on the side. It's a 1/4 strength, so you can kind of think about it, one part of the 4 is Cestacol, and the rest of these parts would be water. So this is going to be fairly diluted. You're going to be able to use 1 part Cestacol for the 3 of the parts to water. Where does the 4 come from? Well, one of the 4, because there's a total of 4 parts here, one of the 4 is Cestacol. Now, going back to the problem, when you start these problems, you're always going to start with the given. The given is 12 fluid ounces of Cestacol. And I know that Cestacol because it tells me it's full strength, so it's all Cestacol over 1 times. So I need the fluid ounces of Cestacol to cancel, so that goes on the bottom. The fluid ounces of solution goes on the top because that's what I'm looking for. Now be careful. The 4 fluid ounces, the 4 goes with the solution, the 1 goes with the Cestacol, so I'm going to put the 4 on the top, the 1 on the bottom. These would cancel, and if I do the math, 12 times 4 is 48. 1 times 1 is 1, so we're going to work out with 48. Now if I look at my units, it's 48 fluid ounces of solution. So how much 1/4 strength solution can you make out of a 12-ounce can? Well, you're going to make 48 ounces of solution. Now let's look at this second one. How would you prepare 240 milliliters of 1/2 strength Ensure from full strength Ensure? And again, I remind you that Ensure is a liquid. Which can of Ensure would you use to minimize the amount of discarded Ensure if the supply consists of 8 and 12-ounce cans? Well, the first thing I notice is some of these are in ounces and some of these are in milliliters. So to translate these, I'm going to have to make sure that both of these are in the same sort of unit. If I go back and look in my conversions, this is what I find. Looking at my conversion, since the answer needs to be in ounces, I'm going to go ahead and change this milliliters into ounces. So 240 milliliters over 1, and there are approximately 30 milliliters per 1 fluid ounce. So if I do that, 240 divided by 30, so this would be 8 fluid ounces. So I'm going to need 8 fluid ounces of the solution. So I'll again look at my strength and translate what my strength is. What does my strength mean? My strength means that there are going to be 1 fluid ounce of Ensure per 2 fluid ounces of solution. Now to start my problem, I'll start with what the given is. The given was 240 milliliters, which we converted. I need 8 fluid ounces of solution over 1. I'm going to multiply it by the strength. The strength is given as 1 to 2, and I need the fluid ounces to go on the bottom of solution so that they'll cancel. I want the fluid ounces of Ensure to go on the top, so 1 to 2. Doing the math, I would have 8 times 1 is 8, 1 times 2 is 2, so I'd have 4 fluid ounces of Ensure is what I need. So I need to make 4 fluid ounces, or I need 4 fluid ounces of Ensure. Now the question says, which one of these would you use so that you would be wasting the least amount? Well, to waste the least amount, I would need to use the 8-ounce bottle, and I would use half of the 8-ounce bottle. So that would be the answer to the question. You need 4 fluid ounces. It would make more sense to use the 8-ounce bottle because there'd be less waste. Okay, let's look at this problem. This problem, I have full strength hydrogen peroxide solution, and I'm going to try to prepare 300 milliliters of 2/3 peroxide solution. So, when I get done, I want 300 milliliters of solution. So that is going to be my given, 300 milliliters of solution. Now, to convert it, I'm going to have to use my strength. So I'll go back and look at my strength. My strength is 2/3. The measurement they're using is milliliters. So what does 2/3 strength mean? It means there's 2 milliliters of hydrogen peroxide per 3 milliliters of solution. Now I want to use this strength and multiply here so that we have something cancel. Now what milliliters of solution is in the top, so I need milliliters of solution in the bottom. I would need milliliters of hydrogen peroxide in the top, and I'll put the corresponding numbers that go with each one. This would cancel, and if I do the math, 300 times 2 is 600. 1 times 3 is 3. Divided out, I would get 200 milliliters of hydrogen peroxide. So, how much hydrogen peroxide would you need? You would need 200 milliliters of hydrogen peroxide to produce this 2/3 strength. And what would you do? You would take your 200 milliliters of peroxide and add enough water to get your 300 milliliters. So basically, you're looking at, if these were 100 milliliters, you'd have like 100 milliliters of hydrogen peroxide, 100 milliliters of hydrogen peroxide, and 100 milliliters of water. Hopefully that makes sense, because you can see there's 2 out of the 3 are hydrogen peroxide, or 2/3 strength. Okay, let's look at this problem. In this one, I'm asked to find how many milligrams of fluconazole are contained in 200 milliliters of 0.2% solution. So what I am given to start with is 200 milliliters of solution. Now, how I'm going to convert it is I'm going to use this strength. Fluconazole, they tell me, is a solid, so I know I'm going to use grams. 0.2% would mean that there are 0.2 grams per 100 milliliter. And remember, the 100 come from because it's a percentage. When you see percent, it's that number over 100. Now, I'll go ahead and label this. It's grams of fluconazole over milliliters of solution. So I'm going to take my given and multiply it by the strength. Milliliters of solution goes in the bottom. Grams of fluconazole goes in the top. So I'd have 0.2 over 100. Now multiplying out, 200 times 0.2 would give me 40. 1 times 100 would be 100. If I divide 40 by 100, I'm going to get 0.4, and it'd be grams of fluconazole. Now, that answer is okay, but if I double check in the problem, if you notice it says how many milligrams, I want to point how many milligrams. And the answer we have right here is in grams, so I need to do the added step of converting the grams into milligrams. So 0.4 grams, and there are 1 gram in 1,000 milligrams. So when I convert that, I've got to take 0.4 times 1,000, so I'm going to end up with 400 milligrams of this fluconazole. So the final answer ends up to be 400 milligrams. 0.4 grams, 400 milligrams are the same, but the question asks for milligrams, so you have to convert it to give the final answer. And here's another practice one. Again, look for your given. I'm given, how would 400 milliliters of 20% solution be prepared using tablets? They contain 10 grams of drug. Well, I need to make 400 milliliters of solution. So I'm making 400 milliliters of solution over 1. I need to look at my percentage, my strength, to get translated into something to convert. So 20%, and it talks about grams, so I know this is solid. I have 20 grams per 100 milliliters. Now, they don't tell me what drug it is. I'll just say drug and solution. So we'll do 20 grams of drug, and I have 100 milliliters of solution because I need the milliliters to cancel. These would cancel. Well, 400 times 20 would make 8,000. 1 times 100 is 100. And if I divide these out, it looks like I would need 80 grams of drug. Well, that's true. I need 80 grams of drug, but I have this last little piece. The tablets each contain 10 grams. So how many tablets do I need is the question. Well, if I need 80 grams and each tablet is 10 grams, I would just divide that out and it would tell me I need 8 tablets. So that would be your final answer. Now, the last thing I want to do is to remind you to study your medical terms, your medical terminology. It was given to you as a handout the last day of class if you came. If you didn't, you can look on Blackboard and it's under Unit 4. But it's those terms that we'll be using with dosage calculations, like PRN stands for as needed, or PO by mouth. There's like BID, TID. Just be used to some of these terms that you're going to see when we start doing dosage calculations.